My name is Pete Chadwick. I'm Director of Product Management for Cloud and Systems Management. With me is Vincent Untz, who's the Project Manager for SUSE OpenStack Cloud. What we'd like to do today is walk you through sort of the latest version of SUSE OpenStack, our 7th release. And since we're the last thing between you and the party, I guess we'll try and move this along as quickly as possible. Yeah. Well, you never know. And please, I'd like to keep this as interactive as possible. We don't have a lot of slides. Just trying to hit the highlights of the release. If there's anything in particular, any questions you have about SUSE OpenStack Cloud in general, if you have questions about OpenStack in general, feel free to ask those as well. We also have some other folks, Andreas Jaeger in the back of the room, who's got some deep knowledge of OpenStack, so we can certainly help out on that. So, for those of you who were here at the first SUSECON, or at the first SUSECON, that's about when we launched our first SUSE OpenStack product. At the time, it was just called SUSE Cloud 1. And it was pretty much based on a fairly simple set of capabilities. You had hypervisors, you ran on x86, and the hypervisors were Xen or KVM. In reality, when we joined the community in 2011, you could have any hypervisor you wanted as long as it was KVM. And we actually put a lot of effort in to get Xen working as well as KVM, and we also did some things into the Nova scheduler to make it capable to have more than one hypervisor in a single cloud. Prior to us starting, most everybody was just running KVM. If you wanted to run Xen, you could run Xen, but it was an either-or proposition. And then everything was really in 5 projects. I mean, you had the dashboard, which is Horizon, which is what both the administrator and the user look at when they want to interact with the self-service capabilities. And then you had authentication. So the manages the logon passwords and also authenticates all the interactions between the various OpenStack services. You had compute with Nova, which was the scheduler. You had images, which got stored in a project called Glance. Then you had object storage in Swift. And it was a nice, simple solution. It was pretty easy to package that up with, message queue, database. Obviously, we built it on top of SUSE Linux Enterprise Server. And as I said, it was a pretty simple, straightforward process to pull this together. This is what OpenStack looks like now. All of the networking and the block storage got pulled out of Nova, set up as separate projects. In the case of block storage, it's Cinder. In the case of networking, it's Neutron. And the reason for that is that it made it much easier to interface networking with a variety of networking vendors, and the same thing with storage. With the first release of storage, the only 2 options were NetApp and Ceph. So now you can pretty much run any storage array behind the storage tools, and there's a wide variety of things you can do on the networking side through partner drivers from Cisco, from Nuage, from Juniper, from a number of people. Perhaps more importantly, on the hypervisor side, you pretty much have all the major hypervisors now available, and we support all of them in SUSE OpenStack Cloud 7. The one that's not up here, otherwise I would have said we support every hypervisor from A to Z, is ARM. We are demoing that at the technology preview, but we have not yet officially put that into the product. And then there's some other capabilities on here, sort of what we call at the API level, where you can now have collect statistics to measure the health of the network, or to monitor what's going on in the cloud, and then an orchestration engine that enables you to define workloads consisting of multiple virtual machines and deploy them in a single command. And then on the side, you see all of these things, which in and some people would call almost microservices. So it's pre-packaged capabilities that rather than, for example, spinning up your own DNS server, spinning up a virtual machine, configuring it to be a DNS server, you can just go and say, I want to, just give me a DNS server and run that as part of the cloud natively. Anything else in here? As I said, we picked up x86. We support Z Systems, ZVM as well. And I think that's the most important pieces of what's happened. So you can see that the project has gotten much more complex. Now most customers, both that we work with as well as customers within the overall community, are typically only using a handful of these projects. Pretty much everybody's using compute, although there are some people that are only deploying OpenStack to do object storage with Swift. But most people are doing compute and images, object storage, block, not necessarily even files necessarily, networking. So I think there's only 8 projects that have more than 50% uptake on the upstream side. So this is more or less what we are shipping with SUSE OpenStack Cloud 7. The other key piece for SUSE OpenStack is that, not on this slide, is we have an installation framework which coordinates the deployment of the physical infrastructure and then putting the services on top of that environment. So as we sit down and go through developing our roadmap, we try to pull together the various engineering activities, the various enhancements, and pull them into what we call themes. And the major themes that we picked for 2016 were evolving the base and enhancements to the base infrastructure. And that includes both the upstream version of OpenStack that we use, as well as the version of SUSE Linux Enterprise Server that we base the solution on. We look at expanding services, so those services that are on the right-hand side of that slide, we look at which ones should we add or which ones should we expand, perhaps move from technology preview to full support. And then we look at how we can make it easier to run a cloud, to operate everything in a consistent fashion. So with SUSE OpenStack Cloud 7, we're moving from upstream Liberty release to the upstream Newton release. We're moving from Service Pack 1 to Service Pack 2. And then we did a number of enhancements to the user interface for our deployment tool. And those were mostly focused around cleaning up the visuals, but also packaging things in such a way that it was easier to manage a larger number of nodes as you're going through the physical deployment. So what I thought I'd do is run through some of the highlights in OpenStack Newton, in the Newton release. And these are really the high level, what we think are most impactful for the end users, for both operators as well as end users. So one of the things on Keystone, and this is actually quite important from a performance perspective, because Keystone not only handles authentication from the end user coming in to get access to the OpenStack environment, it's also every transaction between the OpenStack services has to go through Keystone to make sure that nobody gets onto the network and starts sending rogue commands. So, for example, if you're going to set up you want to deploy a virtual machine and attach a disk drive to it, then Nova has to communicate with Cinder, which is the block storage service, to request a device, a disk to get provisioned and attached. All of that you want to have authenticated. So they've made some enhancements to LDAP to speed up the performance as you're going through the Keystone processing. And same thing with token caching. So all this is managed by tokens. So by caching the tokens, you speed up how much time it takes you to acquire the validation, to acquire the real token that allows you to access the service. And then finally, for increasing system security, we've started encrypting keys at rest. And there was one thing they talked about, I don't have it in the slides here, but we talked about at the recent OpenStack Summit, is there's now OpenStack projects or open source projects are now going through security validation that looks at the processes to identify and secure the various projects or the various pieces that make up the project. And OpenStack was one of the first to receive the stamp of good security process. Horizon is the user interface, both for end users who are trying to use the cloud as well as the administrators that are operating the cloud. So a couple things, again, in sort of keeping with the Keystone, theme, you can now access Keystone tokens more directly from a JavaScript CLI. So this simplifies and provides more flexibility in how you configure your cloud. Again, performance. You can make direct calls from OpenStack services from Horizon into the rest of the OpenStack environment. Custom configs. This is at first I didn't understand what this is all about because it's not necessarily relevant for our customers. It used to be that if you wanted to deploy OpenStack, you had to deploy a certain fixed sets of capabilities. But for example, if you only wanted to run object storage, you still had to deploy compute. And this is the ability to say, okay, I'm just going to use a Horizon dashboard just to manage an object storage solution. So it gives you more flexibility on what kinds of things you can use OpenStack for. And then we've got some additional capabilities for managing networking functions directly from the dashboard. So you can now see what kind of connections you've got in for your networking plugins, and then you can also see what the floating IPs or kind of the IPs that you assign to your virtual machines for talking to the outside world. You now have more direct management you can look at those more directly. Heat is the orchestration engine. There's a couple different modes that you can run that in. It turned out that most customers manage this through what is called convergence mode, and where you try to it speeds up how fast Heat resolves any requests for resources. That was not the default, so they switched to the default just because that was what most people were doing, and it speeds things up. You can now do conditional actions based upon conditional statements. So you can say if this and that, then do something. Previously, it was purely if this happens, do this. So now you can build compound statements, and you can also reference external resources. So you can look at, for example, you have a database that's outside of OpenStack that you want to bring into your Heat stack. You can now do that. And I think YACL stands for yet another query language. So it's a way to build your templates and understand how they work. Nova is the scheduler, the actual compute engine. So a couple key things. You now have policies can be done directly in code. It makes it simpler to manage those. And a number of enhancements for live migration. And we think this is specifically important because live migration underpins doing things like high availability for compute nodes. So live migration is a bit of a misnomer. You're shutting down the VM from one place, moving it to another. But the whole point is that you can, they've made some enhancements to how live migration actually happens. You can do it faster because you wait until the VM is moved before you start copying data on the back-end storage devices. From an administrator point of view, there's now an API so that you can track live migrations that are ongoing. And then one of the things that people are very concerned about is when you are doing live migration or doing evacuation. So evacuation is when I say take every VM that's running on this physical compute node and move it to another one. Originally, if you were picking servers based upon a specific set of capabilities, you would test that when you deployed the virtual machine, but you wouldn't test that when you did live migration. so that you could say, okay, I want this to go on this set of servers because they've got Xeon E5-2550s, and I know that they've got some specific characteristics that I want to take advantage of, or they've got the performance characteristics I want. And then when I do a live migration, it ends up on some other completely different kind of processor with different performance characteristics, different I/O characteristics, different NICs on the back end. So you want to make sure that when I do a live migration, I make sure that it ends up on the same kind of machine that I intended it to at the beginning. And that was a key issue with a number of customers who were doing initial implementations. Yeah, generally yes. You know, but just for whatever reason you choose to say, I want this guy to go here. You want to be able to make sure that when I move it, it still meets those characteristics. Some improvements in the scheduler. And some of these are kind of, they seem kind of arcane, but the idea is that in most, so I don't know if in a cloud environment like Amazon or OpenStack or anything else, a virtual CPU equals a thread. So if you go on Amazon and say, give me a two CPU machine, if you go on OpenStack and say, I've defined a flavor that's got two CPUs and two virtual CPUs in it, you'll get 2 threads off of a Xeon processor typically. So this is, from a scheduler perspective, you can start to look at how do I want to place my guests based upon thread utilization or how many threads are available on a various CPUs. So you give it an additional level of granularity of the scheduler so you can make sure I can get my performance that I want across the cloud. And then in terms of I can actually select my scheduler, I can have my scheduler decide where to place things based upon how much disk is available on that particular compute node. So instead of just saying, give me a general process, give me any processor, you can say, give me the one that's got the most, launch this VM on where there's the most disk. And there's another thing that, which is just called get me a network. And if you decide, if you as an end user are spinning up a virtual machine and don't want to go through the hassle of defining what a network's going to look like on your virtual machine, it just gives you a network. So it just automatically defines a network for you, which can simplify deploying the VM. Which leads into networking. So there's a lot of things going on in the networking space that are around how do I take advantage of some higher level features of a networking environment such as QoS? So now, I can specify, that I want QoS, levels of QoS on ports and on specific networks, and tie that into how I schedule my VMs. This VLAN aware VMs feature is that you can say that when I spin up this set of VMs, they always go on this particular VLAN. So it makes it easier to, especially when you're orchestrating large numbers of VMs, it makes it easier to manage that deployment. Open vSwitch is part of SUSE Linux Enterprise Server, but it's a sort of a precursor software-defined networking. It doesn't require all of the capabilities that a lot of the proprietary software-defined networking solutions give you. It has some performance improvements with the most recent versions of Open vSwitch, and then OpenStack is designed to take better advantage of those. And then this, if you define your networking environment to have HA characteristics, there's some enhancements to make this more responsive, so that when you say I need to move things, I'm getting a failure, I need to move network interfaces to a new machine because I need to fail over some machines, virtual machines, then it does it faster than it used to. Cinder is the block storage device, and so when you start up, again, if you're familiar with Amazon, this is like Elastic Block Store. So it's the ability to define a persistent set of storage, attach it to a virtual machine. If the virtual machine goes away, the storage continues to be available for other VMs. So you can, within Cinder, you define pools of servers or pools of disks that you want to use to provision, from which you're going to provision block devices, virtualized block devices. So you can now weight the pools again. So when I'm scheduling, I might say, for example, I have, I want certain virtual machines to go on this pool because it's slower. And these are not high performance machines. I have another pool that's higher performance. So I can tie this back into the scheduler so that I make sure that I decide which pool gets filled up the first, or which pool do I want to pick based upon specific characteristics. Previously, you can set up the block service to take snapshots. Or you can take snapshots manually from the user console. Previously, if I deleted a volume, I'd have to go in and delete each individual snapshot for that volume. Now, if I say get rid of the volume, it gets rid of all the snapshots associated with that as well. So clearly an ease of use. One of the challenges that we have in OpenStack upstream with anything that requires a back-end driver from, in this case, a storage vendor, or if in the case of networking, from a network vendor, is making sure that the vendors get their drivers upstream and tested soon enough so that we can include them in the list. There have been a couple of vendors that were very angry when the upstream development team said, we need to have your driver by this date so we can get it through testing, or it's not going to be in the release. That happened about 2 times, and then the vendors started getting much more diligent about making sure they had their drivers done in time to make the release. So there's a much wider array of solutions available. I think pretty much any storage array, storage vendor is now has drivers that work with Cinder. So you can pretty much pick anybody at this point. Telemetry is a combination of projects, but it's how you measure what's going on in your system. So again, some of these seem a little down in the weeds. Magnum is a new service that we ship to support Kubernetes and Docker deployments. So you can now do Kubernetes as a service within OpenStack. And what this is an end user can say, I want to start running a containerized workload or a set of containerized workloads. Calls Magnum and says, I'd like to have a bay of virtual machines. The set spins up the virtual machines, configures them with Kubernetes, and then you can just log into the cluster as if it was a standalone Kubernetes cluster and do whatever you want with it from a containerized perspective. So you now have statistics that can monitor the underlying infrastructure to say, this CPU is getting full, it's part of a Kubernetes bay, perhaps we need to scale out the underlying Kubernetes infrastructure to handle the workload. A lot of capability, and I think this is one that's more important from an operator's perspective than perhaps an end user's perspective, but there's a lot more tools to manage what's going on with memory. So if you see a specific server that's either getting a lot of cache misses or you're getting high memory bandwidth utilization, you might want to say, oh, maybe I should start migrating some VMs that are on that particular server off to another server to make sure that the overall performance for my end user stays consistent. Because nothing slows workloads down like cache misses. You start significantly slowing down there. And again, you'll see this is in concert. A lot of this work with telemetry is working with heat. So the fact I can use conditional logic in heat, I can now also do conditional logic in the event trigger. So telemetry will look at what's going on and then trigger events that then can be interpreted by heat to go take an action from an orchestration point of view. So just as heat can now say if this and this, then this. Now the telemetry module can do the same thing. So if disk utilization hits this level and CPU utilization hits this level, then raise an event. And then just to speed up the overall ability of the system to react to events, we now just do batch processing on the message. So the advantage of that is that rather than every time I get an event, I send it up, I pull a number of events together, then put them all on the message bus at the same time. So you can just process them much more rapidly. So now that's kind of a quick level of what I think are the highlights of sort of the user and operator enhancements to to OpenStack Newton from prior releases. So now let's talk about SUSE OpenStack Cloud 6. So from a services point of view, we talked about Nova's the scheduler, Neutron is networking, Cinder's block storage. So we've always had the sort of the base components, as from the slide that I showed originally. There are a number of other projects that we supported. Swift, which is object storage. We've supported telemetry for a while. Oslo is really it's nothing that's ever visible to the end user. It's a common library of commands that all the other projects can use. Similarly, the OpenStack client, to get more consistency in how all of these projects interact with the user, they pulled out the CLIs from all the separate projects and put them into a single project so that you can get consistency. So that in terms of what's the command structure, how do you specify the parameters, how do you specify the if you're working on a virtual machine, how do you specify that? So to get consistency there. Again, nothing that's really visible to the end customer or even to the operator, but it is important in terms of getting an overall improvement in how the cloud works.
The other parts of the chart, the one which is not in green, like the Murano and Paula and all of those things.
Yep.
They are something that you're trying to support in the future, or they are not your products and you're not trying to.
So I can talk about that in the next slide. Sure. So this was SUSE OpenStack Cloud 6. This is what we shipped back in March, I think is when we shipped it. And then you see so anything in green, fully supported, typical SUSE support. Purple tech preview, which means it's in the product, but we don't recommend it for production, and we don't support it, but it's there if you want to use it. Tempest is a test harness, and we just don't think it's particularly relevant for customers to use it. We have to put it in the product because we use it to test internally when we ship it, and we also ship it to partners so that they can do testing as well. I'm not going to go through all these ones in gray. They're just not even there. These we ship the packages, which means the packages are in the product. So if you want to manually configure it, you can do that, but again, it's not supported. All of the ones that are in green, we ship configuration scripts as part of our installation framework so that you can install it and configure it in a nice, easy fashion. So going to Cloud 7, you can see that we picked up a number of projects. So anything that has white lettering that's practically illegible on this projector is a status change from Cloud 6. So you'll see we moved a number of things into Tech Preview. Trove is database as a service. Sahara is big data as a service. Barbican is key management. And Trove and Sahara, we have those as tech previews because we're not convinced that very many customers actually want to use them. So we're putting them out there to get feedback. In fact, I've had I've talked to half a dozen customers that have all said, yeah, I would never do Trove. We'll just do that some other way. Same thing with Sahara. You just set up Sahara is big data as a service, so you set up a Hadoop cluster. Most customers will say, I'll set up a Hadoop cluster and then connect to it from OpenStack when I spin up a virtual machine.
When you say spinning up a Hadoop cluster, I mean you're saying like it's going to actually spin up the whole name node and all the nodes.
Yep. Yep. Still have Tempest in there as a tech preview. Barbican, we know some specific use cases where Barbican is very useful. We're a little concerned about how mature the code is upstream yet, so we'll market tech preview, but there are a couple customers and partners that have specific use cases that we're saying, okay, fine, we'll support it for those use cases. Now, the ones that are in, you asked about the ones that are in gray. I think it's pretty obvious that we're more interested in Salt than in Ansible. If you look at Ansible, O, Cola, those are all deployment tools that are different from how we deploy the product today. So I think it's safe to say we would never do O, we're not going to do Ansible. Cola, maybe, because that's how do I deploy all these other services in containers. And that's something we're going to look at. There are other projects that can do containerized deployment of OpenStack services. So we're going to look at that as part of post-Cloud 7 activities. RefStack, kind of not really terribly useful we don't think for end customers, so we're not going to do anything with that. Courier is also part of, I think that attaches to Magnum, so it's something we may look at, but at this point, it's about containerizing, and that's, so is that networking? Or
it's for networking.
Yeah, so it's for networking with containers. There are other ways to do that may make more sense, as not everybody's going to deploy a containerized environment in OpenStack, that you might want to have a more general solution. Rally is a testing tool, a scale testing tool. So, if somebody wants to do that, they can download it from upstream and run it, but we just don't think it's something that's typically useful. So if that answers your question. If anybody has an overwhelming use case that you really think we need to ship one of these, then we can talk about it, but in general, that's our plan right now. So kind of as a highlight, so from SUSE OpenStack Cloud 7 point of view, some of the key things, we're now shipping Magnum, which again, as I talked about, allows you to spin up a set of virtual machines, deploy Kubernetes on that, and then use that to run containerized workloads. We also, as part of SUSE Enterprise Storage 4, announced full support for CephFS. If you haven't been to one of those discussions, CephFS is a file system that sits on top of SUSE Enterprise Storage. It's a POSIX compatible file system. Manila is a shared file service, so essentially it emulates NFS. And as I like to say, it's the ability to set up file shares without having to talk to your friendly NetApp administrator. It's self-service. You can say, set up a shared folder attached to these virtual machines and manage it just as you would normally. Manila now has a driver that you can use CephFS as the back end for it. So this is the first time as we talk about with SUSE Enterprise Storage 4, Ceph is a fully unified block file and object storage solution, and this just now says I can use SUSE Enterprise Storage as a back end for all of my OpenStack storage services, with the caveats around Ceph performance and things like that, but you can use this as a single solution for all the storage requirements in OpenStack. With SUSE OpenStack Cloud 6, we started support for managing a zSystems mainframe, running ZVM as a compute node in OpenStack. In SUSE OpenStack Cloud, what that meant was from a single control plane, you could spin up VMs in ZVM, or you can spin them up on x86 or VMware or Hyper-V. There's two modes that IBM has for ZVM support. One's called Manage 2, which is I've got a control plane that sits outside of the ZVM environment and talks through their proxy agent to spin up VMs. The other one is Managed From, so we are now where the control plane actually runs on ZVM. So with SUSE OpenStack Cloud 7, we're giving the customer the option of either running the control plane on ZVM or running the control plane externally. The two different use cases are if you've got an environment where ZVM is ZVM and x86 is x86 and the two don't talk to each other, then Managed From is going to make a lot of sense because it now gives you a fully contained ZVM solution to do self-service VM setup. So it gives you the same flexibility, the same ease of use for your end customers to spin up virtual machines as compared to what you get from just ZVM natively. But if you've got a mixed environment, we think most customers are going to put it on x86 and manage into the ZVM. And we've got customers on both sides of that fence.
Why IBM Power is missing in this chat?
I'm sorry?
Power PM is missing everywhere in the Power service.
Power PC.
We have not. We're looking at PowerPC, but we haven't committed that at this point. We've also gotten questions about ZKVM, same answer. We're waiting for customer demand. If there's customer demand, we certainly can do it. There's another project that was on the chart before called Ironic, which is deployment of literally physical server deployment, self-service. So we have some customers that are interested in using that because they'll have a rack of servers available, and they have specific use cases where it can only run on physical. You can now, with Nova, you can say, give me a physical server, just the same way you give me a virtual machine.
You were talking about better support for live migration. Does that include the Ironic component for physical servers as well as the virtual machines?
Question is, does live migration work from physical servers as well as VMs? Probably not.
I don't believe so.
Yeah, because the live migration, I think, is actually limited to KVM. So or I think you can do it to VMware as well, because you can trigger through vSphere. You can trigger a VMware migration. Hyper-V, you can probably do it, but I'm not sure they've implemented it in the driver. So it'd have to be something at the physical layer to do that, and I'm just not aware of it. We've done some things. I think Thomas DiGiacomo was talking during the keynote yesterday about some of the work we're doing around Cloud Foundry. So we're working with SAP to make sure the Cloud Foundry cloud provider interface between Cloud Foundry and OpenStack. We're working together with SAP upstream to make sure that is maintained and enhanced. And then our team also put together what we call a Cloud Foundry validator. So you can run it against an OpenStack deployment to make sure you've got all the components necessary to deploy Cloud Foundry in this environment. We also have been working with a number of partners, Pivotal Cloud Foundry most obviously, to make sure that their solution runs on top of SUSE OpenStack Cloud. We'll also be providing support for a service catalog. This is it's a catalog of services. So you can define things like WordPress. So if you've got users that want to spin up a WordPress blog, you have heat templates that say, you need for WordPress, you need a web front end, you need a database on the back end, you need the following things, and you can just have that so a user can say, just deploy, instead of having the user deploy all the individual virtual machines, configure them with the right services on the virtual machine, connect them together. You now just do that, and you can say, give me WordPress, give me a LAMP stack, give me whatever. And I think that's an area we'll also see some things we're doing with partners. We have some even more interesting ways to do service catalogs in a hybrid cloud environment, so we'll see some enhancements there. And then we do a lot of work with partners to integrate their plugins, and especially working with partners to have their plugins configured as part of our install process. So if you're installing a storage backend, we'd really like to have Cinder, all the parameters necessary to configure Cinder to work with that backend. Some of the things that we call operational enhancements, and this is actually, I think, the most interesting thing we're doing in this release, is that we can now do what we call live migration. And what that means is that if you have running workloads on SUSE OpenStack Cloud 6, when you migrate to SUSE OpenStack Cloud 7, you won't have to shut down the VMs. So they'll be fully operational during the entire upgrade process. The APIs will go down so that you can't start new ones, you can't stop existing ones for some small period of time. Depends on the size of your cloud, but we're talking tens of minutes, not hours or anything like that. But if you've got long-running VMs, or if you just don't want to disrupt any of your customers, you don't have to worry about that at this point. And we think that's a huge benefit from an operational perspective. Now, we've got some things that will ship after GA. One is multi-data center deployment, so that you can have multiple OpenStack environments, clusters running in 2 different physical data centers, but you can manage them, provide a single interface to manage those 2 environments. We're doing something called Virtual Machine HA. And this is dependent upon some upstream work that hasn't. We need to figure out how to configure and manage. So with SUSE OpenStack Cloud 5 and before, we had the ability to deploy the control plane in a highly available fashion. With SUSE OpenStack Cloud 6, we extended that to the compute nodes. So if a compute node fails, we automatically resurrect the VMs on another physical server. So that you, again, get higher availability for your end customers. With this, what we're actually trying to do is extend it all the way up to the virtual machines. There's a couple different projects upstream that we're cooperating with. We're actually cooperating with Red Hat, Intel, NTT around how to solve that. So we'll provide more details, and the intention is to deliver that on Cloud 7. It'll be sometime in the first half of 2018. And then we're also going to be providing some what we call day 2 management. So the ability to make changes in the network post-deployment, as well as better tools for log management and virtualization, so that if there is a problem in the cloud, you can identify what's potentially causing that. And then the install framework itself, we're doing some upgrades to improve scalability. Right now our target is hundreds of nodes in terms of making sure that works well. That's not a hard limit in terms of how big you can make it, but we really want to make sure that if you're standing up 200 nodes, it should work. And then in terms of providing capabilities within the install framework to deploy these new services and configure these new services, we'll add these as well. There are probably other configuration supports that we've enhanced for, as I mentioned, for storage and networking vendors to do their plugins. So this is what the roadmap looks like as we look going forward. So we had Cloud 6 beginning of this year. Cloud 7 will come out in January, and then Cloud 8 is tentatively targeted for fourth quarter of 2018. You can see from a OpenStack, we go from the N release to the P release. There's an O release that'll happen in the middle of calendar 2017. We are not going to productize that. As we do every time, the packages will be available on the Open Build service, so you can always get access to them, but it's not something we productize and support. So the next one is Pike, which is named after the Massachusetts Turnpike, because the next design summit is in Boston. And so this is OpenStack lore. You have to the name has to be tied to a geographical feature of the city in which the design summit happens. So yeah, I can't remember where Newton was from. I mean, where was Austin? It was Austin. There was something in Newton, something called Newton. Anyway. Yeah. But anyway, the Pike refers to the Mass Pike. So one of the things we're looking at is adding support for ARM. As I said, we're demoing it. We're demoing it in the technology showcase. It may just be a tech preview. It depends on customer demand and interest. We'll be testing that over the next few months. Continuing to enhance log filing and analysis, because we think that's a somewhat of a challenge. There are some enhancements going on to heat that we're looking at to make it easier to manage multiple services. The one area that we're from operational enhancements is we are looking at should we containerize the OpenStack control plane. There's some advantages that you could actually put the control plane in containers, and you could orchestrate it with something like Kubernetes, and you get some interesting advantages from a reliability and ease of deployment, as well as an upgrade. So, and obviously, we had questions about ZVM and Power. Those are other architectures that we're looking at, but nothing to commit on the roadmap at this point. So with that, that's all we had prepared to talk about. So I'd like to open it up for any other questions or comments. Yes.
This is just a generalized question. Looking at your graph you have for the roadmap, I was told that OpenStack, you guys were trying to get more on a 12-month release cycle. It seems like at least between 7 and 8, it's maybe just a tad less than that.
So we're trying. So there's a couple things going on. So we're actually trying to get as close to upstream release as possible. So if you look at Newton, it came out in really October. We're just trying to collapse the gap between when that goes live upstream and when we ship things, and that's and to some extent we're much better. I mean, our first releases were like 6 months behind, and we've been collapsing that because we're improving our continuous integration, continuous testing, continuous deployment process on the back end so that we can get closer. To be completely transparent, we were hoping to actually do a public beta that we would have announced 2 weeks ago at the Barcelona Summit. We're just not ready to do that yet. So the goal was to actually have something that could be in the general public. We're in beta, but it's a closed beta. We were actually trying to get an open beta. Now, a couple of things are going on. The upstream releases used to be April, October, and they're moving now to February and August. So they're moving up 2 months. So what that means is that it gives us much higher likelihood that we can, so we'll pull this in, if for nothing else, then we're going to get the upstream release bits, the upstream bits sooner. Now, we're still dependent upon the SP3 release, and and doing all the testing and integration around that. So at this point, we're just saying, well, generically, it should be out by the end of calendar 2017. But the idea would be, seriously, we would love to have public beta the day it drops upstream. It's never going to get, we're never going to be that good. But if we get public beta within 4 weeks of upstream, then I think that would be quite a push forward.
The vested interest that we have, very one-sided on this side, is obviously the quicker that you guys release, it's greater to get the newer, latest and greatest features out.
Yep.
The flip side is how quickly is training services going to get training.
Yes.
And as a training partner, especially one that develops content in a video format,
Yep.
We have to build that into our development cycle as well.
Okay.
Like if you guys are doing it every 6 months, it's like, oh crap, that's going to kill us.
Well, that's why we're not doing it every 6 months, because we also heard from our customers that every 6 months would kill them. So we intend to keep on the 12-month cycle, unless for a miracle something happens. But I'd suggest you just talk to me offhand, and we can make sure, offline, we can make sure that you're synced into the process so that you get access to things as soon as makes sense.
And is it just my eyesight, or is this slide blurry?
It's your eyesight. No, it's the projector. It's my marketing guy's not in the room, so I can say this. We get these templates from marketing, so you got to use this template, and I don't think anybody ever looked at these templates on a projector. so there have been some complaints about that. This projector's not so bad, but some of them were awful. Anything else? Yes.
So the roadmap looks very good, like for the OpenStack Cloud.
Mm-hmm.
As the containerization and Kubernetes is becoming a phase, how would be the future for OpenStack?
So the question was, how does this compare to the Kubernetes and SUSE Linux Enterprise Server and containerization roadmap? There was in fact, I think my colleague Matthias Eckermann, who's director of SUSE Linux program management, was presenting at the same time I was. Otherwise, I would have gone and watched his presentation. And he was talking about what we're doing there to deliver a container-optimized SUSE Linux, and then what we're going to orchestrate around that. Andreas Jaeger, who is a PM on my team, is working on also what that looks like. I would expect that there'll be some enhancements around this time frame for for SUSE Linux Enterprise Server plus Kubernetes plus containers. Does that answer your question? Okay. Okay, if there are no other questions, then I guess we need to go get ready for the demos, right?
Yep.
Thank you.